Math 100 Lesson 5. Question 1 of 13. Evaluate -3 to the third power. So the definition of exponents tells us that we have to take a base of -3 3 times to find the answer to this. So moving left to right, -3 times -3 is 9, times -3 is -27. Now if you want to do this on your calculator, you'll need to enter the parentheses just like you see them and use the caret key that looks like a little arrow pointing up, and that's saying raise -3 to the third, and it will give you the answer -27. The second part, -7 to the second power, means we're going to take -7 twice. So a negative times a negative is going to give us a positive 49. Again, enter it in the calculator, in parentheses, raise it to the second power, and you'll get 49. Now, even though without the parentheses you could get the first one right, you will miss this one if you don't put the parentheses. If you don't believe me, put this in your calculator, and you'll see that it just gives you -49. So if you see parentheses, you have to be sure you enter parentheses in your calculator. Number 2, evaluate the opposite of 7 squared. Now again, if you put it in the computer or the calculator, you have to enter it just like you see it. That's going to come out to -49. And that's because this 2 doesn't apply to this sign because it's not in the parentheses. And then the opposite of -2 cubed, well, that's a total of 4 negatives, because look, there's a negative here, and then there are 3 -2's, and so that's going to make a positive, and that's going to make a positive, so this is going to come out to +8. So make sure you're very careful when you evaluate these. So let's see, we had -49 and +8, and then this one up here was +49. Number 3, they ask us to do 5 to the third over 2. Well, we need to do the exponent first. That's 125 over 2. And since we started out as a fraction, we leave it as a fraction unless it divides evenly into a whole number. So we'll leave that as 125 over 2. -5 over 4 squared means we have a negative sign, and 5 over 4 times 5 over 4. That's going to give me negative, because there's only one negative, and it does not get squared because it's not in the parentheses, 25 over 16. And so those are just some basic rules of numerical exponents, okay? Just using numbers. But now we're going to look at some with variables, and we need a few rules in this case. So the first rule we need to know is that if you have a base, x, to any power, we'll call it m, times, that little dot for times, x to the n, we actually add the exponents. We don't multiply them. Here's why. Let's say I've got x to the second times x to the third. Well, that means 2 x's are multiplied here, 3 x's are multiplied here, and if you count the total, you have 5, not 6. Now, if there happen to be numbers in front of these, 3x to the second times 2x to the third, well, those are regular numbers. They get multiplied. So I would have 6x to the fifth. So when you multiply like bases, you add the exponents, and numbers out front called coefficients, well, those just get multiplied, just like regular numbers, because they are regular numbers. So this will help us to do number 4. Number 4 says -3 v to the 8th, parentheses, -9v. Well, that means multiply. When you have no symbols in between, no add, subtract, multiply, or divide, and you have parentheses, that means to multiply. So I've got a negative times a negative, which is going to be a positive 27. I've got 8 v's multiplied here, 1 more v multiplied here, so we add 8 and 1 to get v to the 9th. Number 5, they give us several factors to be multiplied. So I've got 3x to the 7th times 7w times 2w to the 3rd, x to the 5th. So let's just start with the numbers. 3 times 7 times 2. What we're actually doing is we're using a property called commutative, which says if you've got multiplication, you can rearrange it. So 3 times 7 times 2. And then I've got an x to the 7th. I'll rearrange it and put x to the 5th beside it. And that w is w to the 1, w to the 3rd. Now, most of the time we do this rearranging in our heads. But if you want to rearrange them, you can, because multiplication is commutative, meaning I can do it in any order I wish. 3 times 7 times 2 is going to be 42. Just take out your calculator, multiply that. I've got x to the 7th and x to the 5th. Well, I know I'm supposed to add when I multiply, so that's x to the 12th. And now I've got a total of w to the 4th. Because remember, if there's no exponent, it's implied to be a 1. So this one is 42 x to the 12th, w to the 4th. And I forgot to write this one, so I'm going to go back up here. This is 27 v to the 9th. So number 6, 16 y to the 2 over 12 y to the 5. Well, this is a fraction, so what we're going to do is we're going to reduce it. But before I do that, I'm going to rewrite some things. I'm going to write my 16 as 4 times 4 and my 12 as 4 times 3. I'm going to write the y squared as y times y, and then on the bottom I've got 5 y's all multiplied. Now I don't have to do it this way, but I want to do it this way just to show you why this works. We've got all multiplication on the bottom and all multiplication on the top. Nothing added or subtracted. That means I have the ability to divide numbers that are alike. 4 goes into 4 one time. 3 won't go into 4, so I'll skip that. Y goes into Y one time. Y goes into Y one time. So all that's left in the top is a 4. But on the bottom, there's a 3, and 3 y's multiplied together would be y cubed. So look what we really did. We reduced the 16 over 12 like it was a fraction. By the way, your calculator can also do this for you. Let me create some space here and show you the keys on your calculator. So this is for the TI 32XS, that 30X2S that's required for the class. If you're not using that calculator, you may have to figure this out on your own how to do it. But remember, all calculators for tests have to be approved. So there's a key on your calculator that looks like this. It's got an A and a B and a C. Okay, that's the fraction key. If you type in 16 fraction key 12 and hit enter, it's going to give you 1 and 1/3. Well, that's the mixed number for 4 over 3. If you press second and the fraction key again, it will give you 4 over 3. So all of the fraction work in this class you can do on your calculator. Now let's talk a little bit about these exponents. Look what we did. We did not actually divide the exponents, we subtracted. 5 subtract 2 gave me an exponent of 3, and because the 5 was in the bottom, these 3 y's end up in the bottom. So that's 4 over 3 y cubed. Number 7. In this problem, we have x to the 3rd raised to the 5th. So this is different from before. We have a power, or an exponent inside, raised to a power, or an exponent outside. Now this rule is going to be to multiply, because what this means is we need to take x to the 3rd 5 different times. We're not going to use this long way, but I want to show you so you'll know why it works. Each of these is 3 x's being multiplied. And the definition of an exponent is how many times do you take the same number and multiply it times itself? 3, 6, 9, 12, 15 times. And look how we get the 15. We multiply those two numbers. So when you have a power, x to the m raised to another power, you multiply. So this one is x to the 15th. Number 8. 3u, all in parentheses, raised to the 2nd power. This would mean take 3u twice, and because it's multiplication, it's commutative, I can rearrange the order, and you'll see I get 3 squared u squared, or 9u squared. So this tells us that when we have multiplication in parentheses raised to a power, we raise each factor, that is, those numbers being multiplied, to the power. And again, some of this you can just do in your head. 3 squared is 9u squared. So this one is 9u squared. Have to remember to square both parts. So number 9 is very similar to this. -4, a to the 4th, b to the 3rd. So it's -4, a to the 4th, b, all to the 3rd. Okay, so everything in here, and because this first number has a negative, I'm going to put parentheses around it. And these exponents I'm going to multiply because it's a power to a power. You can do the -4 to the 3rd on your calculator using the caret key. That's going to give you -64. A to the 12th, b to the 3rd. So -64, a to the 12th, b to the 3rd. Number 10. So now we have a fraction raised to a power. It's going to be very similar to the product, like these last two raised to the power. What you're going to find out is, instead of writing this thing 5 times, I'm going to need to raise each factor of the numerator to the 5th and the factor in the denominator to the 5th. Now that y is positive, so I'm going to just leave it y to the 5th. There's no minus sign down there. Do this on the calculator, -32, x to the 20 over y to the 5th. And there's nothing to reduce here because there are no other numbers, and x's and y's cannot be reduced. Okay, those would have to be the same base in order to reduce. So -32 x to the 20th over y to the 5th. No parentheses. Look, they say write it without parentheses. That just means expand it. Find out what the value is. So number 11, we experience the 0 exponent. Take a moment to just do 5 to the 0 in your calculator. You're going to see the value is 1. 100 to the 0. The value is 1. So any base raised to the 0 power is 1 unless it's 0 to the 0, which is undefined. Okay? We don't do that one. But everything else is going to be 1. So the opposite of 5 raised to the 0. Now be careful, this negative is not affected by that 0, so this is a -1. 1/7 raised to the 0, that's going to be a +1. And now just a couple of review problems. 4x squared times -3 x to the 5th, positive times a negative, -12, x to the 2nd, x to the 5th, multiplied, add your exponents. -12 x to the 7th. Number 13, 2y times 8y to the 8th, v to the 8th, times 2v to the 6th. We can rearrange in our head, or we can say 2 times 8 times 2, y times y8, v8 times v to the 6th. 2 times 8 is 16 times 2 is 32, y to the 9th, v to the 14th. So these are some problems that deal with the laws of exponents. And just a quick recap on the rules. Let's just do these real fast. When you multiply two bases that are alike, you add your exponents. When you divide two bases that are alike, you subtract your exponents. If the bigger exponent is in the bottom, though, your answer, your base to your power will be in the bottom. And we're going to talk about that a whole lot more in the next lesson. So just remember that when you divide, you subtract your exponents. When you raise a power to a power, you multiply your exponents. Think about that parentheses meaning multiplication between those two numbers. When you have more than one thing in parentheses raised to a power, each of those is raised to the power. Remember to always use parentheses if you see it in the problem, if you're doing it on the calculator, and know that there is a difference between the opposite of 4 squared and negative 4 squared. This one is negative 16 because the sign is not affected by the power, and this one is positive 16.